Hello, this is the luckiest maths teacher in the world. Today we're looking at conditional probability. What that means is we're going to find the probability of an event given that another event has already occurred. So, an example of something we might calculate using conditional probability, let's say I roll a normal six-sided die and I want to figure out the probability that I get, say, a 2, given that I got an even number. So this line here means given that. So I'm saying basically I rolled a die, I know I got an even number, so since I know that I got an even number, what's the probability? It's a 2. So obviously this is different than the probability of just getting a 2 without knowing that the number was even, okay? Now I'm going to explain this using a Venn diagram again. So, here's our Venn diagram again. So let's think of A and B as the events in our question. So A is going to be the event that I got a 2, and B is going to be the event that I got an even number. So during the Venn diagram, we actually don't need to draw the Venn diagram for this, but I just want to show you. So A is the event that I got a 2. So I'm going to put a 2 in A. And of course, B, the event that I got an even number, I could get 2, 4, or 6. Now, as I told you in previous videos, instead of writing the 2 twice, we're just going to write it in the middle. So I'm going to get rid of that and put the 2 in the middle. Okay? So you can see that the probability that I get a 2, given that I got an even, well, there's 1, 2, 3 possibilities in B. So I'm telling you that I'm in B. I'm telling you that it's an even number. I'm not out here with 1, 3, and 5, okay? That would be a different question. So I'm telling you that I got an even number. So I'm in this circle here. So I want to find basically the probability that I'm also in this circle here, in A. And so the probability of that is just, well, there's one way I can be in A and also in B, and there are 3 outcomes in total that are even. So basically what I'm saying is the probability of 2 given even is the proportion of outcomes in this section of the circle compared to the outcomes in the whole circle, right? So the way that we write this is the probability of A, given that B has already happened, equals the probability that I'm in this part of the circle. So it's the proportion of outcomes in that part of the circle over the total number of outcomes in this whole big circle here. So it's the proportion of outcomes from this big circle that are in this little area here. Okay, sorry about all the lines. So that's the formula that we can use for any conditional probability calculation that you encounter. So just to show you that I could have used the formula, and it's a lot quicker than drawing a Venn diagram, obviously. So I'm going to calculate this probability again using the formula down here. So probability of A and B, the probability I get a 2 and an even number, well, that's just 1 over 6, because if I get 2, then I do have an even number. So the probability of A given B is 1 over 6. There's one way it can occur, and there are 6 outcomes in total. And I divide that by the probability I get an even number is 1 over 2, because there are 2 outcomes possible. I can get an odd number or I can get an even number. And of course, 1/6 divided by a half equals a third. Simple. I'll give you one more example. Now please copy this slide down if you want to keep it, because I'm about to change. So the question I'm going to do is, let's say I draw a card from a deck, and I'm going to tell you that that card was red. And given that that card was red, I want to find the probability that the card was a diamond. So I'm looking for the probability that I picked a diamond card given that the card was red. Okay? So the way I do this is I use my formula. I'll write it again for you. Probability of A and B over the probability of B. So the probability I get a card that is both red and a diamond, well, that's just the probability that I get a diamond. So there are 4 suits in a deck of cards, so diamonds is one of them, so there's a quarter chance that I get a card that's a diamond and red, and the chance of getting a red is a half. So then the answer to my question, given that I have a red card, the probability it's a diamond is a quarter divided half, which is a half. Okay, and that makes sense, because if we get a red card, it could either be a diamond or a heart, so 1 in 2 chance. Now notice that the probability of that it's a red card, given that it's a diamond, is not the same. So make sure you don't make that mistake. You've got to make sure you get the order right. Probability of A given B is not the same as probability of B given A. So the probability of getting a red and a diamond is a quarter. So probability of A and B. So this is my new A. This is my new B. Probability of A and B is a quarter as it was before. But then the probability of B of getting a diamond is a quarter. So the answer to that is 1. And that makes sense. If I get a diamond, it's definitely red. It's certainly going to be red because diamonds are red in cards. So probability of red given diamond is a quarter divided quarter, which is 1. One more thing I just wanted to note was that if 2 events are independent, then of course that means they don't affect each other, right? But what that means is that the probability of A given B is just going to be the same as the probability of A. Okay, so for example, let's say I toss 2 coins. So I'm going to toss 2 coins, okay? Now I want to know what is the probability I get a head on the second coin, given that I got a tail on the first coin, okay? Now that, of course, getting a tail on the first coin doesn't affect what I get on the second coin. They're independent, so the probability I get a head on the second coin is still going to be a half, which is just the probability of heads, okay? So that's only for independent events. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.